Hello, in this video we're going to be looking at some different problems and trying to determine which derivative rule we need to apply for that problem. So in this first one I can see I've got just a constant next to this function I want to find the derivative of. Since it is just a constant with my function, I can just find the derivative of f of x without any worry in the world. If we're adding two functions together, that is not going to cause us any trouble. We can just find the derivative of these two bits individually, plug in those values in order to figure out what the derivative is at that point. Multiplying by a constant and adding two functions together doesn't change how we would find the derivative. In this example, I've got two things being multiplied together. Since they are being multiplied and not added to each other, that tells me I need to do my product rule, which means I need to do the derivative of that f of x multiplied by g of x, and then find the derivative of g of x multiplied by f of x. So we got to do all of that rigmarole. Once we do that rigmarole, we're able to plug in those values into x, evaluate them at those points, and find our derivative at that point. If we've got a division, we need to do the derivative of the top times the bottom. Then we'll have a minus, and then the derivative of the bottom times the top. You're not helping, you know. Once we get that, then we can start plugging in our values and see what we end up with. No, you are trying to bite me. That's not cool. Ugh. In this example, we've got a composition of different functions. We've got f of x inside of g of x. So that's telling me I need to do the derivative of the outside using the chain rule to find f prime, leaving that inside alone. No. And then find the derivative of the inside. This part f is also a composition of functions. It's a composition of f with a square root function. So same deal that we did over here. We need to do the derivative of that outside, that 1/2, multiplied by the derivative of the inside, the f of x. Once we have done that, we can evaluate that. And we can do the same thing over here with this one. But these are both chain rule problems. In this example, this could be done using quotient rule. We could do the derivative of the top times the derivative of the bottom, blah, 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 blah. However, it would be easier if we just turned that into a g to the -2. Then we would just be able to apply our power rule and the chain rule. Sorry, still chain rule though. But that would be a little bit easier than trying to do our quotient rule. Both would work. This is just going to be a little bit simpler. This example is a composition of multiple different things. So I do see that I have a chain rule because I've got that 1/2 going on the outside. So that's telling me to do the derivative of that outside bit, which gets me this. But then that thing chains, and I need to find the derivative of this inside bit. Now that's an addition, and so it's two functions being added to each other, so I can find the derivative of those two pieces. What's the derivative of the first bit? The derivative of the second bit. Now these two bits are then going to chain. I'm sorry. Yeah, they are going to chain because we have an outside function, this square, and then that inside function, that f of x. So we get a chain rule from this piece and a chain rule from this piece. You can see here, I'm just kind of copying that same thing down over and over, but it might help to kind of like, since there's so many things going on here, jumping straight to this is a bit extreme. Having these intermediate steps can help you out. The type of differentiation that we haven't covered yet is implicit differentiation. So in this one, we're looking for the tangent line through this point. I'm mostly interested in finding that derivative so we can see that example of like, what type of differentiation do we need to do? So this first part is just a regular power rule. So we can just make that a 12x. We've got a series of things all being added together, so we can take the derivative of each bit one by one to figure out what sort of rules we need to apply. In our next bit, we've got a 3, an x, and a y. So we've got two things going on there. We've got the 3x and we've got the y. So we want to find the derivative of the first thing. So this is going to be plus 3, the derivative of the first thing times that second thing, which is a y, plus the derivative of the second thing, which is a y. So that is going to be an implicit differentiation. So we get that y prime, or a dy over dx, multiplied by our second thing, which is 3x. This next piece, when we find the derivative of that, we do have to chain rule on that one. That one's a bit more complicated than the y because we have that squared on the outside. So we do our power rule, so we get 4y to the first, multiplied by doing a chain, the derivative of the inside, which is y prime again. Then we get a plus this 17y. It's going to work very similar to when we found the derivative of that y earlier. So it's going to be plus 17, ooh, come on, y prime. Finally, we have the derivative of a constant. The derivative of a constant is going to be 0 minus 0. And then on the other side, we have another constant, which is 0. So that will also be 0. And there is our derivative of that thing. We would use that to figure out what our tangent line is, but that's not the point of this video. I just wanted to look at how that implicit differentiation fits with these different types of derivatives. So concludes our video on different rules of differentiation. Reminder, if you've got that nice power rule, do the power rule. The tricky thing is making sure that you understand the difference of product rule, quotient rule, and chain rule. Some of these can happen inside of each other, so being mindful of like, okay, well, this is the part I'm trying to find the derivative of. How do I do that part? Thanks for watching. Goodbye.